Yes, good afternoon, everyone. The today's class will be going to discuss regarding this DH parameters and the execution, how it is being executed in the case of the real-time robotics and the concept of working either in industrial sector and for different activities that are being progressed in the case of material transfer, even the domestical cases of sectors. The major applications regarding this is the commencement of a work upon its orientation and prismatic movements of the links upon extinction and performing the task within the environment that is being surrounded. As we all know that the work related to this synonym is named as the work volume. Work volume. So coming to the review of 4 different points related to this Dinavit-Hartenberg principle. First one is the zeroth joint, and this is the first joint. I'm considering this as the joint number 1. Let's say that ZI, joint number I, and the link which is being attached to it in order to carry the previous link, and hence the joint that is named here is Z of n I minus 1, and simultaneously the joint which will be attached with respect to another link which is forwarded to the ZI link, ZI joint is ZI plus 1. So this is the ZI have taken the reference considering as a base joint, and the link which is attached towards the left corner of it is ZI minus 1. And the link which is attached towards it simultaneously having the another one more joint in attachment with the right side link, that is Z of I plus 1, and characterizes its 4 parameters, defines the perfect movement, and based upon the movements, either the movements or motions creating on the links based on the existing joints or the types of rotatory joints and the revolutionary kind of joints on fixed axis, and the prismatic movements that are being taking place with respect to the links. Hence, it is very much clear that we need to be aware related to the length of that particular link initially, to which the extension need to be taken place, or the space that will be occupied to move in its surrounding area throughout its axis, which revolution takes place. And if this A of I minus 1, which is the length of perpendicular between the joint axis, joint ZI and the ZI minus 1, this is the length that specifies the area that is being occupied throughout its surroundings based on the fixed axis and the work that is being taking place throughout its revolution, either in a clockwise direction or else in the counterclockwise direction. There's the first point, the distance between 2 successful joint representations. Indeed, to commence the work phenomena surrounding its area. That's in our robotics language or in our robotics subject we will be calling as work volume or work envelope, the space which is being occupied by the robotic end effector. So here we are considering this as a link, and let us assume this joint as an the end effector which is joined here, and the space which is being occupied upon the revolution based on this joint by this end effector, and this will be occupying some space upon its complete stretching throughout its surroundings. So that is called work envelope. So that is the first phenomena need to be get approached. Hence, A, the length of each normal from the joint offset. And the second point need to be approached is theta value. So what is here the theta value represents? And this is the theta. And based upon this theta, the shifting of coordinate frame will be considered either upon theta rotation of the link. It may be entering into the ZX plane to YZ plane, or else from the ZX plane to the XY plane, and that will be depending upon the polarity of or sign of the theta. Either it may be the positive theta or negative theta, and the value of the inclination existing towards it. That is the second point. And coming to the third point, based upon this rotation, the link will be shifting from one plane to the another plane. It is crystal clear if the theta value is greater than 90 degrees. If at all the sign parameter is considered either in the positive or negative orientation, or else negative signs or positive signs, nominally after crossing the 90 degrees of theta value, the shifting of the plane is considering according to our global coordinate system. So XY will be having mutually perpendicular, that is 90 degrees. YZ, that is mutually perpendicular 90 degrees. ZX plane mutually perpendicular, that is also having theta 90 degrees. So hence is a common, each and every axis is a common perpendicular axis among the three axes. Hence we'll be calling this mutually perpendicular to each other. There is a global coordinate system oriented. And there is a third parameter, nothing but the shifting distance from one plane to the another plane when it is being referred with respect to the basic frame. For example, that will be clearly visualizing in our one of the example also. The theta is being changed, and hence it is entering from X planar representation to the Z. And for example, XY we are considering, and from X to 90 degrees has been changed, and this theta value of 90 has been provided. It will be entering into the YZ plane. That is the point here. And shifting of the XY plane to the YZ plane. Hence, this robotic arm or end effector is being entering from XY plane to the YZ plane. That's the point here it is. So that will be entirely perpendicular with respect to the EX. So EX is in this way and Z is here. See, it is quietly perpendicular axis because 90 degrees and axis was different and perpendicular. See, common perpendicular. And the distance, how much distance the shifting angle will be existing with respect to the base. So what is our base here? This is the base considering. And upon rotation of theta, the shifting distance, and this will be the di distance we need to be measured. And the fourth parameter need to be identified here. It is the phi representations. Phi is nothing but the orientation. Orientation, and this is the phi orientation. So how much this orientation towards the clockwise, about the fixed axis of rotation towards its zi, towards the zi link, and xi minus 1 linked with respect to the xi axis. So how much inclinational difference with respect to its orientation will be existing when compared again to the base axis. That is the phi value. Here, if you have been considered, just like the problem we have been solved in the homogeneous matrix, the rotation, the transformation towards the x-axis, towards the y-axis, and towards the z-axis. Here we'll be having the common formulation also here. And here, the theta represents here, the theta represents the rotation, and alpha represents the orientation. Right? And as this Dinavitt-Hartenberg matrix as a transformation matrix from one coordinate frame to the next coordinate frame, and it will be getting varied from one coordinate frame to the other coordinate frame, because the end effector or else the links will be having different geometrical specifications individually. For example, this is the length that is having the length of 15 centimeters, and the another link may be having only the 10 centimeters. And if the end effector is being holding on the link number 2, then the values will be quite different when compared with respect to the base axis. And that's the first point. And the second point here it is, if the links are having the common distance among almost all the links based on the joints with respect to the equal dimensional characteristics, will be achieving the sinusoidal variations based on the links upon its operations, and inclinations can be observed with finest results. And the transformations here can be calculated by utilizing this DS parameter matrix on and combinationally. So in the case of homogeneous matrix, we'll be following the individuality of formulation. But here, for each and every link, depending on the type of joint and supporting with respect to the joint, from the base phenomena onwards, what are the different types of theta fluctuations are existing in the link 1, and link 2, link 3 will be specified clearly in the form of a tabular column, and even the orientations also will be specified with respect to our tabular column. For each and every link, we'll be observing the characteristics. Whether if there is not any changes existing in any of the axes, either it may be of the x or y or z, then simply we will be allocating 0 towards that. See here, for example, let us considering the first row values related to the link 1. Right? So here, what is the link 1? Zi supporting. And here link, remember the joint, based upon the joint, we are specifying the characteristics. So for this, we are calculating the entire specifications. So initially, what is the representations here and towards the, here first one is towards the A and towards the theta orientation and towards the z axis. So here the x axis alignment, here the y axis alignment, here the z axis alignment, and this is the distance or shifting distance with respect to an inclinational factor or else nominal deviation. There is nothing but the translatory motion. If at all the translatory motion does not exist, simply we will be obtaining the end effector position by specification of its length, because The end effector will be fixed to the link, and hence this link dimension and its length will be clearly specified. Hence a of I minus 1 is the length in between this joint and this joint. Nothing but the length of this link, and hence here it is being specified. And upon rotation, either in the clockwise direction in the sense will be having the positive sign, and negative in the sense minus signature. And based upon its coordinate frame, depending upon its theta, if the shifting is being taking place, related to the trigonometric value will be identifying, and what's the shifting angle and shifting distance we will be allocating here in the place of y, and simultaneously in the place of z. And this is the unitary matrix for three-dimensional. And these are the trigonometrical values related to the x comma y comma z based on the link 1, link 2, and link 3 parameters. Hence, this table will finalize the result to be captured very much easily. Instead of being individually or calculating individually the rotation towards the x-axis and the translation, and the results which has been obtained in the case of this rotation need to be again multiplied with respect to the sliding motion calculations, and we'll be obtaining another one more answer. And that answer, if we have another one more link based upon the rotation, we'll be getting another one more result. So upon calculation of these two results, we have already obtained one gratitude result, and that gratitude result again should be multiplied with respect to the additional joint which is having, and further mostly will be happening or obtaining the another one more result, and final result will be of that kind. So instead of calculating these many different steps in an unitary way with simple calculations according to the tabular column representation, we'll be identifying the physical parameters for each and every link. What are the changes occurring in case of its links based on these TH parameters is very much easy to calculate and obtain the results of its transformation and specifying the end effector position to which the machinery components or tool aspects will be attached, and performance of work can be examined very much in detail. So we'll be having once again the glance, that is theta, the rotation about its z-axis, d distance on the z-axis, a is the length of each common normal, that is joint offset, base joint, alpha, the angle between two successive z-axis. So successive z-axis in the sense two different planar representations. The first one is a coordinate system. There's a base coordinate system. Next one is a working coordinate system. Let's have a simple example how to calculate the transformations towards the kinematics of a robot with DH parameters. So see here, the tabular column clearly specifies is an example with respect to this base, and link 1 is the link 1, and this is the joint 1, and this is the link 2, joint 2, right? And the end effector will be existing towards it. And if you have been considered, this is the base axis representation, and this is the secondary axis representation, and from this the theta change about fixed axis, there is orientation taken place, and depending upon that, see, upon rotation is an orientation. Upon rotation, the axis of z towards 90 degrees, change its position here, just do. And coming this y2 to n coordinate frame, this is the frame changing y2, and this x2 is an axis shifting length, and this is the shifting length. So upon rotation, the shifting has been taken place, but the shifted axis will be parallel to the already comparable value, nothing but the t value. And this is the parallel, this is the distance that is shifted from the base channel to the work environment, and end effector will be attached to this, and the work will be commencing here at the end, and hence this is the shifting or work coordinate system, and this is the running coordinate system. So just before to the working coordinate system, running coordinate system, and primarily it is the major coordinate system or base coordinate system will be calling. This is an example of three revolute joints. Three revolute joints, and three revolute joints in it, according to our coordinate system, unit number 1, we are having different types of coordinate systems of a robot. First one, it is an Cartesian coordinate system. Second one, it is an spherical coordinate system, cylindrical coordinate system, third one, and finally the articulated coordinate system. In the final, first one, Cartesian will be having three or prismatic joints, prismatic movements. So మీకు స్టార్టింగ్ లో ఆల్రెడీ చెప్పడం జరిగింది, ఎందుకంటే ప్రాబ్లమ్ సాల్వింగ్ వచ్చేటప్పుడు ఈ కోఆర్డినేట్ యాక్సిస్ అనేవి మనకు క్లియర్ కట్ గా తెలిసి ఉండాలి అని. ఫస్ట్ స్టెప్ లో అయితేనేమో three prismatic joints, that is P, P, P. So only the sliding joints will be taking place, hence it is not suitable with our example. Here clearly mentioned that only three revolute joints are existing. The second condition, it is cylindrical or spherical coordinate system. So spherical coordinate system lo oka revolutory joint ఉంటుంది, రెండు prismatic ఉంటాయి, hence it is not suitable. And third one వచ్చేసరికి polar coordinate system, two revolute joints or rotatory joints and one prismatic, it is also not suitable. Finally, we are having the articulated coordinate system or jointed on coordinate system, which is having three R joints, that is rotatory or revolutory, revolutory, revolutory. So three R manipulators are existing, and the present taken example also having the worst interaction with respect to that jointed arm type of coordinate system with the three RRR representations. Here, those three representations based upon its work at each and every link based on the joints and its positions will be specified according to the representations here. So representations in the sense in each and every link, and this is the I, how many links are existing or how many joints are existing, and second one is an alpha of I minus 1, and hence this is nothing but the if there is any orientations are existing or not in that particular joint will be specified related to each and every type of joints. Next one, A, the distance between the one joint to another joint will be specified here, and D, if there is any shifting angles existing at each and every link will be specifying here, and theta in that particular joint, if there is any shifting angles, then it will be clearly specified, rotatory or revolutory. We'll be having the detailed look here. Coming to the first point, and here I is nothing but the types of joints, and this is the base joint here being communicating in the tabular column as 0, and this is the first joint, this is the joint number 1, and this is the second joint, and this is the joint number 2, right? That is the representation, and we are having four different parameters. So first one, it is an nominal distance between one link to the another link, and next one theta, rotation, and third one, it is an shifting angle, and fourth one, it is an if there is any orientation. So first we will be following at this point, joint number one. So joint number, sorry, zero, base joint zero. So zero లో వచ్చేసరికి orientation ఏమన్నా ఉందా? So there is no any orientation here, but rotation is being possible, and hence orientation ఏం లేదు కాబట్టి simply will be taking with respect to the zero. And distance, so from base joint నుంచి ఈ joint already ఉందే base లో, and hence there is no any length from the base, hence we are assigning with respect to the zero. Next, d, nothing but the shifting distance. So like the shifting distance, so there is no any shifting distance from the base to here, because already this joint is existing in the base, hence the d is also zero. And coming to the theta we are having nothing but here it is clearly specifying with respect to the arrow mark representation. We are having the clockwise or counterclockwise representations, and that will be indicating here. So we are having theta, and hence the theta is processing at the joint of origin, and hence O and theta suffix O have been taken. So in this way, we will be assigning the values for our DH parameters, so 4 parameters. So 4 parameters, so these are the 4 parameters. For those parameters, at each and every joint, we need to represent these synonyms. So at the joint number 1, we are having only the rotation part, and that is theta naught. And the theta naught may be of 30 degrees, maybe 60 degrees, throughout 360 degrees, it is possible. And either maybe if the clockwise or counterclockwise, it is possible. And hence it is represented with theta suffix 0. And next, moving on to the joint number 1. This is the first joint. This is the first joint. And here, first joint, again, verifying these 4 different parameters at the first joint also. So coming to the first orientation. Is there any orientation here? There is no any orientations, either clockwise or counterclockwise. Hence, assigning at the joint number 1. So joint number 1, there is no any orientation, and hence it is 0. Second one, it is a distance from the base. So what is the base to this particular joint? This is the joint number 1. This is the base joint. Hence, for this joint, the base is also existing at the 0 joint only. Hence, we kept here 0. But this joint number 2 is existing with respect to this A0 distance from this base joint. And hence, A0 is the length of joint number 1 when compared to the base joint. ఇక్కడ నుంచి ఇక్కడికి A0 అనేది distance ఉంది, and hence it is clearly specifying here A0 is the distance. Next, shifting angle తో రిలేటెడ్ గా ఏమన్నా డిస్టెన్స్ మెయింటైన్ అవుతుందా, లైక్ దిస్, షిఫ్టింగ్ ఫ్రమ్ ది బేస్ కోఆర్డినేట్ సిస్టమ్ టు అదర్ కోఆర్డినేట్ సిస్టమ్. సో ఇక్కడ షిఫ్టింగ్ అనేది డైరెక్షన్ చేంజ్ ఏం లేదు కదా, షిఫ్టింగ్, and hence we are allocating for the joint number 1, there is no any shifting distance. Hence, is there any theta representations? Yes, arrow mark here clearly specifying the theta representation. So orientation అయితే ఉంది, hence related to the theta at the joint number 1, see, is processing at joint number 1, and this is joint number 1, and at the joint number 1 we are having the orientation and specified with theta 1. Moving on to the joint number 2. Coming to this joint number 2, this joint number 0 origin, joint number 1, joint number 2. Yes, coming to the joint number 2. Is there any orientations happening at the pin oriented pin joint? Yes, direction change is taking place. So it is deviating the aligned position to the directional change position. So ఇది pin చేసుకొని this link is being revoluted. So revolute అయింది కదండి. Here there is no any revolution. Maintaining the sequence series. And here change it. Oriented. So this is the orientation. This is the rotation. Here we will be having a detailed difference. This is the rotational factor and this is the orientational factor. Changing of its flow and changing its direction. Okay, మన elbow అంటాం. The water will be circled by the pump and by different channel maintenance or changing different directions, it will be moving from ground floor to the overhead tank by imparting pressure through the pump or by motor. So upon this orientation, we'll be having the shifting of distance because the direction is being changed when compared with respect to the base frame. The axis will be parallel, but the distance will be getting maintained because the channel will be getting deviated with respect to the orientation. Our orientation ఎంత జరుగుతుంది? Here it is 90 degrees. So 90 degrees here clearly specified. And that 90 degrees also either clockwise అంటే ఇది counter clockwise అంటే that's it. When compared from origin axis నుంచి చూసుకోవాలి. సో మనకైతే మనం ఇప్పుడు చూస్తున్నాం అనుకోండి, అది రివర్స్ అవుతుంది. ఇక్కడ కూడా చూడండి, arrow mark here from the base onwards it is clockwise and అటు సైడ్ కనుకుంటే కౌంటర్ క్లాక్వైజ్. అదే నార్మల్ గా మనకు ఫ్రంట్ వ్యూ అయితేనేమో ఇది కౌంటర్ క్లాక్వైజ్ అని అనుకుంటాం అండ్ నెక్స్ట్ టువర్డ్స్ దిస్ ఇట్స్ అండ్ క్లాక్వైజ్. And here for joint number 2, hence it is considered this way, that is minus 90, right? So 90 degrees orientation is processed and at the joint number 2, this joint number 2, for this joint number 2, orientation taking place at the range of 90 degrees in negative axis or counterclockwise direction. There is minus 90. Okay, next one. Is there any distance happening? Yes. From when compared with respect to the base to joint number 1, it's the distance, and that distance already happened with respect to joint 1, and extension to the joint 1, what is the distance that we are having? There is A1, and yet the end of A1, at the length end of the A1, the shifting has been taken place by its orientation, and a distance entandi A1. So normal length వచ్చేసరికి A1. సో అక్కడ మళ్ళీ ఎక్స్టెన్సిబుల్ మెయింటైన్ చేయడానికి షిఫ్టెడ్ డిస్టెన్స్ ఎంత ఉంటుంది? ఇస్ దేర్ ఎనీ హ్యాపెనింగ్ విత్ షిఫ్టెడ్ డిస్టెన్స్? ఎస్, హ్యాపెన్. ఎందుకని? ఎప్పుడైతే మీకు ఆల్ఫా ఉంటుందో, ఫై యాంగిల్ ఉంటుందో, కంపల్సరీ ద వాల్యూ ఆఫ్ డి అనేది ఉంటుంది. హెన్స్ దిస్ D2 here clearly specifies the shifted distance, that is D2. Finally, is there any rotational factor existing for the joint number 3 or joint number 2 as per our diagram? Here we have taken 0, 1 and 2, and hence this is a joint number 2, and yes, here the arrow mark clearly specifies rotation that is being taken place throughout this z-axis. Hence the theta is 2, theta at the joint 2. So theta is existing for the 3 different joints. అది మనకు ఎలా తెలుస్తుంది? arrow mark representations చూడండి. throughout its base joint 0 horizon position లో, yes it is having arrow mark మళ్ళీ ఇక్కడ ఉందా, and next we will be having the theta 1, theta 2 joint 2 దగ్గర ఉందా, yes it is having. సో di ఎప్పుడు వస్తుంది? డిస్టెన్స్ షిఫ్టింగ్ జరిగినప్పుడు. షిఫ్టింగ్ ఎప్పుడు జరుగుతుంది? ఆల్ఫా వాల్యూ కనుక ఫర్ ఎగ్జాంపుల్ ఇక్కడ సెకండ్ లింక్ లో ఆల్ఫా వాల్యూ ఉంది బికాస్ ఇట్ ఈస్ హ్యావింగ్ ది ఓరియంటేషన్ అట్ -90. సో అట్లాగే ఇక్కడ కూడా -90 ఓరియంటేషన్ ఇక్కడ కూడా జరిగిందని అనుకోండి. సైమల్టేనియస్లీ విల్ బి హ్యావింగ్ at this particular one also similarly like this. Here -90 or -180 or positive 90, whatsoever it may be. If the shifting, and hence if the orientation has been taken place by this, then the flow direction of the axis with respect to the base axis will be getting changed like this joint number 2, and hence you will be having the shifted distance. ఇక్కడ ఎలా డిస్టెన్స్ వచ్చిందో సైమల్టేనియస్లీ ఇక్కడ కూడా డిస్టెన్స్ అనేది అలాగే వస్తుంది. అండ్ హెన్స్ అప్పుడు ఇక్కడ కూడా d1 మే బి ఆబ్టైన్డ్. బట్ ఇక్కడ మనకు లేదు కాబట్టి, స్పెసిఫై చేయలేదు కాబట్టి, ఈ జాయింట్ అండ్ సీక్వెన్స్లోనే ఇచ్చారు కాబట్టి బేస్ జాయింట్కి only the distance between this joint number 1 and joint number 0 will be specified. So simultaneously, in this way, based upon these 4 different parameters, there is A, D, shifting distance, theta, there is rotation, and alpha, there is revolution or orientation, shifting of its angle, or shifting of the entire coordinate frames also will be considering depending upon this alpha value only, right? So that is the calculation have to be commenced based on this DH parameters on each and every joint and has to analyze the end effector position. And notice that the table has two uses to determine the robot with variables and parameters. And next one it is to determine the state of robot which is having the numerical values for its variables. See, these are the representations that we have been identified. And upon calculating this, the base variable position with respect to the global coordinate system, with respect to this base coordinate system, global coordinate system, the transpose will be happen. So to the vectors, so initial x0, y0, z0, okay, with respect to that, what is the translationary two ordinates that are being existing. Finally, we need to obtain this v of x2, v of y2, v of z2. So here v represents the transformation towards the vertex 1, vertex 2, vertex 3. And the overall transpose from the 0 to the first translation, and 0 to 1 translation, and 1 to 2 translation. If at all another link is being existing here, so another translation. So to use the DH parametric, I minus 1 link, 0 and I is equal to 1. So I minus 1 link is the 0, I is the 1, right? So upon this calculation, upon substituting the values depending upon the x or y or z, the sign values, so universal values. So if it is z alignment, the rotation happens towards the z axis. We all know the formulation is this one, matrix formulation. We'll be calculating this first link with respect to the calculation of this z ordinates. Next, the second, first joint number 0 will be calculating towards the z frame. Next, the joint 1 frame, 0 to 1 transpose, that the values will be substituting here. If at all this a1 has been given with respect to the 5 units, that 5 units will be specified here. And theta 1, if anything theta 1 specified is equal to 30 degrees, then 30 degrees will be substituting here. Cos 30 minus sin 30, sin 30 and cos 30, like that. And we'll be having one value. And next 1 to 2 will be having one value. And if theta 2 has been specified, and we'll be substituting here. And d2 value has been specified. For example, it's an for 3 units and a1 is 2 units, and we'll be substituting those values. And here also the theta value for the theta naught is being specified as on 45 degrees. We'll be substituting this value and we'll be obtaining the matrix value. And here also we'll be having the matrix value, and here also we'll be having the matrix value upon substituting of the results will be obtained. So the total matrix will be identified here. So the values obtained here into the values obtained here matrix into the values obtained here matrix into. Upon these calculations, will be concluding this base transformations. This is the conclusions. The movement of the tools. So the end effector position from the world coordinate system. So it is from the origin position to after complete transformations, rotation jarugutundi, extension jarugutundi, shifting of the angle jarugutundi, malli orientation jarugutundi, and shifting distance, normal distance, అన్ని క్యాలిక్యులేట్ చేసుకున్న తర్వాత అవన్నీ ఎప్పుడు వస్తాయి? These values upon calculating this overall transformation. And this is the conclusion formula. And based upon this, we will be, in this way, we will be substituting the values. And in the examination point of view also, the theta values will be specified to you, A values will be specified to you, D values will be specified to you, and phi value also will be specified to you. And that is the way of calculating the position of the end effector upon the overall transformations by utilizing the DS parameters. This is the derivation related to the DS parameters. Thank you. We'll be meeting in the next class.